Gentlemen, welcome back to the shop. Chortle and a churro at the expense of an industrial pita kit. We are going to have a look-see at this modified sine wave inverter in commiseration of Canaderp's Minister Prime himself, Dandy Socks, outright legalizing Tijuana bluegrass, taxing of the devil's herb. There is nothing like legalization to take the profit motive out of all kind of illicit activities. We're having a look at this on account of I don't need the solar powered shed anymore.
Wait, what? Where am I? What is that 60 hertz hum? Why is it so clean? Why does it sound like a Charlton Heston blue-eyed Arab in the sky movie? Pickles, we're eating pickles. Don't ask so many fucking questions, all right? Christmas is coming, and Santa Claus is watching. We're going to juxtapose this $200 Canaderpian peso inverter with this $600 Samlex 1500. This is used for solar systems, quite supposedly. I haven't been into the guts of her, but very much more robust. Now, we saw in the design of this guy, all those jelly bean parts, all just ripe for a cascade failure. All you need is one of those diodes in there. You saw that big bridge. You can go and check it out in a previous video. Also, the beauty of Cunningham's law indicates that not only am I an idiot, but people are very quick to point out wherein I make mistakes. So we weren't completely sure the topology of this guy, whether it was a switch mode power supply or a push-pull. And the Pixie Wranglers in the crowd and amongst us were quick to point out that this is a very nasty push-pull system. And that's where we get the modified sine wave. This is not a pure sine wave inverter. This is a modified sine wave, and we saw on that square wave. Now, the thing is, guys wanted to see a worse load on there. So this thing's been eating asparagus all week. Nastiest load I could find. It's got two big capacitors and it's a big monster rotary inverter. Okay, so this is a compressor motor. Pretty much nothing worse for tripping breakers in your house. So we're gonna see if we can't fuckulate these good and proper. We're in like saying and lifting up the petticoats just vaguely, a huge material difference. Aluminium all the way around. And huge aluminum heatsink with a couple of, looks like blow fans. So come in here through the front and blow out the back, all of the heat sinking, big monster heat sink. All kind of titillating bits. Unfortunately, the walled garden is going to stay walled for the time being. These abortive son of a bitchin' things are tri-wing fasteners, I don't have here. So we'll go ahead and test this. I'm going to show you the startup spark here. We'll get rid of the glare from the chrome dome to enable you to see better. Now, the reason this happens, of course, you know, when you plug something in like a charge air and you get a big blue spark, you think to yourself, holy fuck, that's kind of scary. The reason that is because there's capacitance in that system, probably a large amount of, comparatively a large amount of capacitance. So why is capacitance? Why does that make a spark when you have capacitors in there? Because what's happening is you have two platins. A capacitor is two platins separated by a dielectric material, essentially an insulator. The closer they are together, the better. Now, what happens is if you have a negative and a positive, on the negative side of the platin, pixies rush into that platin and populate it. And because circuits, electric circuits need to be in a circle. They need to be attached, Kirchhoff's current law being what it is. What happens is the equivalent amount of a positive charge builds up on the obverse platin. So you get negative pixies over here, all dour and down in the muck. You get happy little holes over on this side. And when you first connect it up, there's nothing there. It acts like a short circuit. The pixies are free to charge in there and fall over each other in order to fill this platin up. as the charge builds up, it gets harder and harder for the pixies to get in there and squeeze into all the little nooks and crannies. But essentially that's why when you hook this up to something that is highly capacitive, it acts like a short circuit until the pixies populate the one side of the platen. And now you will see there's no spark. Why is that? Because the platens are charged up right full of angry pixies. We had our handy dandy oscilloscope out, and fair is fair. We ran the MotoMaster eliminator on the grinder, so we're going to do the same for this guy. Take a screenshot here, well, waveform, and see what kind of nasty noise we can get. There's that modified sine wave, and you can hear it. Let me get my lapel mic close. It's not nearly as noisy as the cheaper version. The inverter is standing by as witnessed by the square wave. One interesting little bit here when we turn it off and then back, you can see it loads up, and hello, anytime now. Not liking what it's seeing. Strange. Oh, there we go. Okay, so I have the FFT on as well. Now this is not a spectrum analyzer, it's just a very low-end oscilloscope. So we've got 200 hertz per division and the center on 940 hertz. So what was I going to say? Yeah, it's not that great, but we will see any kind of spectral harmonics. If it's real nasty, we should be able to pick it up. I, quite frankly, haven't had much luck with using the FFT in this device. Probably mainly a problem between the steering wheel and the driver's seat, but also this is not what that instrument is designed for. It's not a spectrum analyzer, as I said. So we're going to run the grinder, and I'll focus out here. And it does not. Oh, there we go. All right, something funny going on there. And it does not like what it's, maybe low voltage on the battery. But you saw that waveform, there was some fucky shit going on there. Everybody's favorite. Hey, if it were easy, I'd be out of a job. Troubleshooting. We're gonna turn this on here. On the output, 1.2 volts AC. Something going on, and the waveform completely fuckered. Let's check the battery voltage. Okay, 11.6, titty bit low. We'll slap that on the charge air and hope for the beast. Flash up the grinder. Much better, as it was faulting out previous, so we clearly didn't have enough battery charge. Now we dropped down, we took the surface charge off. It's connected up to the charger, no big deal. And now we're running 1 amp in standby here. Oh. And the overload. Oh, it doesn't like it. I'm gonna try taking the wheel off, just that little blonde one extra of inertia. Holy fuck, easier said than done. I need to call my wife. Oh, hernia. Fuck you. Now that is an interesting trick. Watch this again. If and at first it doesn't chooch, try again with your finger clamped on the trigger. I'm going to zoom right in on this leading edge here, on this rising edge. You see that little bit there? So this is the zero volts. Here's the AC going one way. Here's the AC going the other way. So we're gonna zoom right in on that section, changing the scale to 100 volts, and we'll move the position up a little bit here. Trigger, and we're on 5 microseconds per division. Pretty quick. Failed, and now coming up to speed. Now it's maintaining the voltage very nicely, and the battery is taking a shit kicking. We're already down to 2.3, or 12.3 rather. Where the fuck are we to? The day is the morrow. I brought this in. It very likely will not work. Holy fuck. Camera's going bananas. Un momento, por favor. You'd be excused for thinking that bumblefucking around in the privacy and comfort of your own empire dirt would be easy, but you add in some technology here, and holy old fuck. Good times come in little packages. First time's free and so forth. Oh yeah, triggered. Why are drugs so fun? Okay, thank you. Gonna flash up the grinder app to see what kind of action we can get, as witnessed by the kilowatt. Now the kilowatt is designed, it's probably tweaked for perfect sinusoidal and very little difference in power factor. This will be lagging power factor, but it's not a sinusoidal waveform. However, something. According to our super scientitious $30 instrument, seems to cut out around 8 amps. Now we're having a weeboo at the Moto Master version. We're looking for that hard edge on the positive, down to, what the fuck is going on there? 50 microseconds. We're worried about this section right here. You don't know until you know, and there you go, now you know. I wouldn't have guessed it. This cheaper, much cheaper version has a under load, far nicer waveform, less noise, less chopping up, less everything. It's patently obvious to the most casual observers, however, that neither of these will run this nasty inductive capacitive load here, this motor. So not even gonna try. But what we'll do is have a look-see at the internals on account of I finally got the proper tri-wing going on. Well, not tri-wing, triangle drive. Now, before we get into it, we'll take heed to the manufacturer's label. Wouldn't want to get hurt here. Well, the thing is, this high capacitance, right? But normally there's so we're safe there. Normally there's a bleed down resistor in betwixt the between of the capacitors, so that if you turn it off and you let it sit for a while, slowly but surely the charge in the capacitors bleeds down and leaves you safe. But the other thing you got to check is try lockout, tag out, and test. You got to test it to make sure it's de-energized. Oh, you see, son of a bitch and thing tried to kill me. And we're in the, whoa. Oh, hello, cascade failure, my old friend. Look at the MOSFETs on this cork stuffer. Hundreds of them, thousands of them, all paralleled up. Okay, so these appear to be, yeah, no name, and they're not matched. We got a CET here, we got KI, wow, and another CET. Okay, wow. So this more expensive one than the cheaper one, that's in cost only. Looking at the embodiment here and the topology, it's essentially the same unit. Some salient differences, of course. in this case, we have so many of these MOSFETs that are paralleled that the thing is, MOSFETs are, especially in this case, they're not matched. And I made a mistake when I said, when I was doing the previous one, when I said MOSFETs normally fail open. That's completely wrong, as indicated by the electrical engineering precept that MOSFETs or transistors always protect fuses. So generally the MOSFET is what blows up first prior to the fuse blowing. So if you have a blown fuse in here, and this is kind of a pain in the arse, we have these ATX automotive style bayonet fuses, and they are soldered right into the board. In the case of the cheaper unit, they are replaceable because they're in sockets. In this case, you need to desolder them to replace them. However, if you have blown one of these fuses, chances are you've cascaded a failure through a number of these MOSFETs. So yeah, I mean, just the sheer number of these, and what we're doing here is we're linking these in a chain, and it's only as strong as the weakest link. But no, it's not a chain, because a chain is seriesed up like this, but these are in parallel. So what you're getting is rings all holding a load. Well, now one of those fails. Now the load is shared between fewer of these MOSFETs. Then the next one down the chain fails, and so forth and so forth, and you get a cascade of failures. It's a push-pull configuration, and we see, well, you want to go with conventional or electron. We'll go with electron theory. Angry pixies come in here, split up 4 ways into these, again, paralleled transformers. Each little section here is, we got capacitors in order to filter out some noise, and we have also to store energy, and we also have a transformer here. Now a transformer doesn't work on DC. That's why we need these MOSFETs to energize and de-energize the circuit, and that changing electrical field creates a changing magnetic field, which allows us to inductively couple the primary side of the transformer to the secondary side. And then physically, how many wires we have in there determines how much voltage multiplication we get. So in this case, well, in the cheaper Motomaster case, what we had is a big toroidal core, a high permeability magnetic core, and we only had a half a wrap of wire. We just had the big beefy wire going right through the middle. Now you consider this to get inductive coupling, that is to get a magnetic coupling, all you have is one wire going through the core. The mind boggles. How does electricity even work? But work it did, as we see by the waveform when we tested it. So what's going on here is, instead of having one big core, they've got 4 littler ones. Maybe, and that is weeble wobbling all over the place. Yeah. I'm surprised that it's so expensive. What are you paying for exactly? Your guess is as good as mine. Now here's the motherboard, as you say, on a 90-degree riser. This is the brain box. It's got a little beeper. That's where our sound comes from. So this would be all the control module. And we have some output filtering, some Mylar caps. Really not much to it. Having a look now at these, seeing if we can get the macro. You see they are not matched. We got different manufacturers, CET, this guy's different than this guy and different than this guy, and then these 4. Okay. Well, this might be doing some other function. These guys are all the same. These guys are all the same. One thing, as I said, these fail in closed. They fail closed, so they short out. IGBTs, what you would see in a variable frequency drive, are quite a bit more robust, and they're more expensive. IGBT is an insulated gate bipolar transistor, So what happens to those when they fry is they go open circuit. So that's where I got cocked up, as I was thinking IGBTs, and I got tongue-tangulated with the MOSFETs. Having had a look at the components, there's nothing special in here, all craptacular components, no name brand stuff going on, no real physical robusticizing. I don't see why this would be so expensive. The only thing that's really on outward appearance better is the heat sinking, of course, far more thermal mass. Aluminium's not that expensive. Engineering wise, it doesn't appear to be any better. Maybe there's more testing involved, and definitely you're paying for the name brand. That's quite a well-known name brand in the solar industry for sure, but well, the proof in the pudding's in the currents. There it is, a couple old raisins. Well, this is the Empire dirt, and fuck-ups are par for the course, but this is beyond the beyonds. Okay, so I figured I'd get the O-scope connected back up so that I could just confirm that was a messy waveform, because I might have had the settings different, you know, different days, different, same shit, different pile. Okay, look at this though. I go to set the lead up, the Jesus thing is flapping in the breeze. Flapping in the fucking breeze. So that might have been why we got some fucked up readings. Now I actually do not have a soldering iron here. Once again, for the second time, I got the Samlex under test here, 500 microseconds per division. We're looking at this hard edge right here, and we're also looking at the voltage if it sags before it faults out. Because the cheaper one, it sagged down. It was like 90 volts, 95 volts, something like that. So that's quite a bit better. That's good. Now we know the reason it was jiggling all over the place was because that wire was loose. In the cold, hard light of day, this has been very edifying for me, and hopefully an eye-opener for you as well. Well, it's a huge eye-opener for me. Why in the fuck did I spend $500 on this fucking piece of shit? What's no better than this piece of shit? In maybe an electrical engineer or power engineer could, well, very much appreciate your considered comments down below me about what are the advantages of this guy. Why are you paying so much more money when the quality doesn't seem to be, well, the quality in this case, maybe we got a dud. It happens, but you're paying for that name brand, which you would think you wouldn't get a dud. But the fucking thing had one of the power leads flapping in the breeze. What the fuck, over? I have no problem at all paying more money for something that's better quality. It's not gonna burn my fucking house down. But, you know, the hot lead flopping in the breeze, that is just not acceptable, partner. What's the advantage here? It's just more money. It doesn't make a sense. Where is the extra money? Where's the extra money gone to? Where's the beef? Down below me in the doobly-doo, your comments, very much appreciated. Thanks for watching. Keep your dick in a vice. Holy fuck. Like paper in the wind.